And that's Charlie. He didn't realize that. Some of it is going to waste. Some of the names that I remember are going to waste.
Okay, 1 second. I just gotta write the time.
My friends, Michael wants to introduce himself formally.
Hello, I'm the SI leader. Hello.
Hello.
So I'm the SI leader for this class. What that means is I'm going to provide like supplemental instruction. It's going to be like practice over topics we went in class, and the times are going to be Monday from 4 to 5:15 and Lerted 11:31, and then Wednesday 5:30 to 6:45 and 11:31. And basically, we'll be doing like practice problems, practicing over topics we covered in class, and just giving some like supplemental instruction over topics. So if you want some instruction, come.
It'll be on the campus.
Yeah, it will be on campus. Yeah, so come from those times. Thank you.
Put those times on Canvas so you can see it. All done? Sorry. All good? Okay. So basically, you will have some SI leaders in your other courses, but in our course, Michael is the only one. And he runs the SI sessions that he runs extra additional practice, basically. You can go in there and listen to him go over additional problems. Say again? And I will add that to the syllabus module where it says help room, tutoring, and SI. There's like one link. I will add that information. I'll take it home and I add it. Do you guys remember what we were doing last time? There were shapes. What shapes were they called? Quadric surfaces. Quadric surfaces, and then we discussed cylinders. This is still section what? 12.6, quadric surfaces. We discussed cylinders. Cylinders were missing a variable. The two other variables were 2 power 2. We discussed the parabolas. Either elliptic, which look like the bowl, or the other parabola was what? Did I say parabola? I meant paraboloid. Elliptic paraboloid, or we talked about hyperbolic paraboloid, which was a saddle point. And then we discussed ellipsoid, which is a football. And we discussed 3 other items: cone, hyperboloid of one sheet, hyperboloid, that's boloid, of 2 sheets. So 3 items in there. With paraboloid, you're expecting one of the variable to appear of degree 1, the other ones to appear at degree 2. With these 3 and ellipsoid, you're expecting all of them to appear of degree 2. The standard ones, right? There are non-standard ones that do other stuff. But the standard ones, they're all appearing of degree 2. These always, one variable has different sign. So now the picture over here, do you see this? It's always in this case. The one that has a different sign is z. Right? If I put the z to the other side, z squared is going to be negative. And the only difference between these shapes, you see that the constant is changing. That constant changing changes the shape. Sometimes you have hyperboloid of two sheets, which is right now. For one instant, one quick moment you had a cone, then it became hyperboloids of one sheet. Fair game? So that's how it is. What is different between all of them? That part is the same. This part is the same. That constant A is different between the three of them. And the recognition for me is basically, I try to do, in these three cases, none of them are shifted. What does mean not shifted? They're all like, all the symmetries are about the origin. The symmetries haven't changed. There hasn't been any transformation moving them around. Why am I on one page? There we go. There we go. So basically, these are not moved around. Here, when the symmetries, the axis of symmetries at origin, I can see that the constant 0 gives me cone. And one way I can check this, can you guys tell me which variable is not like the others in here? Z. Can you give me, for the variable that is not like the others, give me a value for a cross section that only gives me a point? What should I plug in for z equal to get only a point? 0. If I plug in z equal to 0, then what I have is x squared over a squared plus y squared over b squared equal to 0. That is only possible when the x and y are both 0. So I get only 0, 0, 0. So if you can find that, that's automatically a cone. That tells me this is a cone. That's only between the three of them, cone is the one. Again, in your lab, you're going to do a lot of cross sections to get used to it. But sometimes we want you to quickly pick what surface matches what shape, what formula. And to match the surface to the formula quickly, this is the trick for me. Now, over here, right, which one is not like the other? Z. Now I plug in z equal to 0. When I plug in z equal to 0, cross section z equal to 0, what do I get? Is this possible? That is not possible. So I get nothing. I get empty set. No cross section. And this no cross section only happens when I have hyperboloids of two sheets, because there is a gap between them. And then you can test this one, you can see that there would be a point. Here, z is not like the others. If I plug in z equal to 0, for example, you want to be around the center of symmetry. Here, center of symmetry are at the origin. So z equal to 0, and then if I plug that in, I get what do I get? This is an ellipse. So it's a hyperboloid of one sheet, because there is no gap in between. Here, gap. Here, a point. Here, there is nothing. Everybody's doing this now. Let's do this with your next door neighbor. You're crossing it, right? You have the cone like this. This is also helpful. For example, you have a cone like this. You're crossing it until you get here, and it's just a point. z equal to. The one that is not like the others, that tells you the axis that the shape is laying toward. Z in here is the one for both of them. It goes through the z. Questions? Doing good? Okay. Let's do quick examples and then do a bunch of eye clickers. You guys are ready? So I want to compare these two. Tell me, all the variables in power 2? No, which one is not? Z in these two cases. So surface A, surface B, they cannot be those surfaces or ellipsoid, right? We have to go back to the surfaces that we had before. What were the surfaces we had before? Paraboloids, right? Because one of them is of degree 1. You see a parabola. When you have one of degree 1, the other one's of degree 2. Fair game? Why am I expecting paraboloids? Because one is degree 1, the other ones are degree 2. Parabolas are like that. Y equal to x squared. X equal to y squared, right? Those are parabolas. So you see cross-section with parabolas. You just have to, from there, go. So the first thing it's saying passes vertical line test. Vertical line test. Does this one pass vertical line test? If I feed a point to x and y, does it give me only one z? Yes, check mark. How about that one? You give me an x and y, it gives me one z. So basically, that's a function test that you're doing. Now, for x equal to a constant, what do I get? Give me z equal to 3k squared plus 4y squared. If this is a constant, what do you have? Parabola. If what direction does parabola open up? Y and z. This way or downward? Upward. And for y equal to k, I get z equal to 3x squared plus 4k squared. And I write up next to it. How about this one? Parabola again, that's the constant. Upward, upward. Now for z equal to k, if I plug in k, do I always get an intersection? No, when do I not get an intersection? For what value of k? For k less than 0, no intersection. How about k equal to 0? What do I get? I get 3x squared plus 4y squared equal to 0. That only can happen when x and y are 0. So I only get a point. For k bigger than 0, what do I get? Ellipses. So parabola, parabola, ellipses. Which kind of paraboloid is this? Elliptic paraboloid. Fair? So that one is elliptic paraboloid. And I forgot to write up in here. Now, over here, if I set x equal to constant, what do I get? I get z equal to 2k squared minus 5y squared. Is this parabola upward or downward? This is the constant. It's downward. That's down with a D, not a clown. And how about this one with y equal to constant? This one is upward. That's the constant, right? And then how about k equal to 2x squared minus 5y squared? It's always possible, right? This one is always possible. You do this in your lab. It just depends on, for k positive or k negative, you can get this way or that way, or two lines. When do I get two lines in here? When k equal to 0, then you get 2x squared is equal to 5y squared. That's x. 2x is equal to plus minus 5y. Oh, my bad. There was a square root missing. Right? So this, what did you get? The last one was a hyperbola. So this paraboloid is going to be hyperbolic paraboloid. All good? Should I show you the pictures? Elliptic paraboloid looks like a bowl. Not to be mistaken by the hyperboloids of two sheets. That's two bowls. That one is just one bowl. And the hyperbolic paraboloid is just a Pringle. Fair game? You guys are ready for example? Oh, one more example on my side. Okay. Let's try to find the interesting part of this. Right? What I know for x equal to constant and z equal to constant, those are the ones with the same sign. Right? These two are the same sign. Y is not like the others. If I set these two up, you can quickly see that, what do we get? If I set x equal to constant, what do I get? So I either get a hyperbola or I get two lines. And then over here again, you set it up z equal to 0. Where did k go? I apologize. And again, hyperbola or two lines. So that seems like it's a hyperboloid, right? So that much I know. I have to decide between my hyperboloids. It's either hyperboloids or cone. Is it a cone or a hyperboloid? Or is it hyperboloid of one sheet or two sheet? How do I test? I go from here. Give me, let's start with 0. Y equal to 0. What do I get? Is this possible? No, because I'm writing it this way, maybe this is more obvious. Two non-negative numbers don't add up to be negative. So not possible. So there is a gap. So what kind of hyperboloid is this? It's not a cone. It's a hyperboloid of two sheets. Let's do examples. Are you guys ready? Get your eye clicker out. I kind of spend more time than I was hoping to do. Um, you this way, I'm that way. John and Gingen. Did I say that? I can't remember your name again. Del. Forgot their name also. Do okay? Do you know the answer? So if I said x equal to constant, what do I get? Small constant. Not zero, but small constant. What do I get? Oh, I have one. But they have to keep it though.
They have to keep it?
I'll bring another one next time. They keep it and give it back to me next time. They keep it for the entire semester. So if I said x equal to constant, what shape do I get? If I said x equal to constant, I get, let's say put x equal to, let's put x equal to 1/3. No, let's put x equal to 1/9. What shape do I get? I get an ellipse because 9 divided by 81 is 1/9. Subtract from the other side. You get 4y squared plus z squared equal to 8/9. Right? For small enough z, I get an ellipse. How about if I do that with y? What do I get? Again, ellipse. How about if I do that with z? Choose a small enough one of them. Because if I choose big ones, it's not going to intersect. So every direction, you're getting what? What shape do you get every direction? You get an ellipse. Ellipse. Okay, did everybody get that? Did you get that? Everybody's okay? So every intersection, every cross section you did, you got what shape? Ellipse. Was there a hyperbola? No. Was there parabola? No. Was there a line? No. 4, 3, 2, 1, 0. So here you see all the signs are positive. When I put them all in one side, they're all like each other. Now this one is not like the others. What do I do? When one is not like the others, what shapes am I expecting? Do you know the answer? What's that? If I plug in z equal to 0, I get a circle. So it intersects, yes. Did that make sense? Everybody's okay? It's going up. What are you guys getting? Why? Because I plug in z equal to 0, it intersects. It's just z, whatever value z you plug in is possible because it goes to the other side and becomes positive. Natalia. Why am I cannot pronounce anything right? I'm going to destroy your name. Oh, what are some of your names quickly? Miriam, Marianne, Novid, Noman, and your name? Quinn. And what's your name? Louder. Angelina? Angelica? Yes, hold. K is a constant. Plug in a constant. Okay, so I'm walking down. What is the answer, my friends? Do we all know the answer? Can I stop? 4, 3, 2, 1, 0. Yeah, that's correct. Come on. How about this one? Quickly. Oh, no. What happened? This is the one we're doing. Quicker. I need to teach one whole section after this. What is the answer? 2 sheets. Why? I plug in z equal to 0, I get nothing. 4, 3, 2, 1, 0. And 2 sheets. And do one more. Now that you're on the roll. Is this one of these? Why is it not one of these? Is it one of those? Does parabola show up for this one? It shows up, right? Because one is degree 1, the other one is degree 2. No? Yes? Are we set? Do you see hyperboloid? In cross sections, do you see hyperboloids? Hold on. How do I see hyperboloids? X equal to constant, y equal to constant, or z equal to constant? If I set z equal to constant, positive constant, I see an ellipse. I see a circle. So I really don't see hyperboloid. I only see parabolas, and I only see ellipses or circles. What shape would that be? Yeah. Did everybody catch that? So all intersections are parabolas or circles. 4, 3, 2, 1, 0. Come on. Go for this one. Do you remember what was the last one I did? Last one was this. Everything has moved. Things have moved. Are you expecting all 3 variables of degree 2, or one of them should be 1? One should be 1. Why? It's an hyperboloid. You see hyperbolas, right? Wait. So 2 of them are out. No, one of them is out. That one is out because everything is of power 2. The last one. Last one is out. Now, where is the vertex right now? Vertex, where is the vertex? Vertex right now is at 3, 1, 0. So X moved 3 steps, And so it should be x minus 3. And y moved one step, so y minus 1. Right? Which direction is it going? X or y or z? Which direction is it opening? Y. So which variable should be of degree 1? Y. So do we have one that is ding, 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 ding? Okay. Did you get that? So I have 4, 3, 2, 1, 0. Come on, there we go. Do you guys want to do some of these iClickers, or do you want to teach a little bit, then do iClickers? Well, I don't have enough time. Let's teach a little bit, and I do iClicker out of, like, from another section. Fair game? I don't have enough iClickers for this section. I think it would work well. Okay, so now we've talked about this, and then we want to deliver. We're talking about functions of 2 or more variables. How does this work? With function comes domain and it comes range, correct? So when I talk about function of 2 variables, let me write my notes right here. F goes from R2, oh, sorry, my bad handwriting. F goes from a subset of R2 to R. So you choose a subset of R2, you choose a subset of plane, and F acts on that. That D is the domain. What is domain? Every input that you can put in. Okay? So what does this do? F acts on a point on R2. What is point in R2? X and Y. Then it spits out a number that is just a real number. Function of 2 variables. That's the function of 2 variables. Now I want to define the range of this thing. Range of this thing, so the domain is the set that F acts on. Domain is set of all inputs. Write down all inputs. Range is all the outputs. Range, the set of all outputs. How do I show it? For showing it, am I writing big enough? Can you guys see it? Okay, thank you. And so to show it, you write this way. Z equal to f of x and y such that x and y is, do you guys know this means in the domain. If you haven't seen it, it's a good time to learn it. That sometimes people call it epsilon, sometimes call it the lowercase epsilon. It means in. Means this point is in the domain. So that's the range. It's just everything set of all the outputs that you're putting in. So all the outputs gives you a Z. Okay, let's do some examples. Now, one thing I want to say that I didn't say right now, these two are independent variables. That one is the dependent variable. So, function of one variable, y equal to f of x. Which one is independent? X. Which one is dependent? Y. Which one is input? X. Which one is output? Y. When I go to function of two variables, independents are x and y, and then dependents are z. then the independents are input, the output is Z, right? So that's how it goes. This goes here. Oh, no, my example's right there. Let me do an example, upside down example. Okay, so in here, let me think about this. Z equal to f of x and y. F of x and y is square root of x squared plus y squared minus 1. Give me a point that I can plug into this. Point in R2. You guys give me a point. 3 and 2. So what is f of 3 and 2? Let's see if it works. X to power 2 plus y to power 2. Why am I having that 2 over there? Minus 1, square root of 12. So this function, if I plug in 3 and 2, it gives me square root of 12. Now you guys tell me, what values can I not plug in? Oh, 0 and 0. Can I plug in 0 and 0? No. That's bad. Let's do that. Okay. So can you tell me exactly the sets that I cannot plug in? Set of points that I cannot plug in. Anything, the set that makes this part negative. So opposite of that is the set that makes this part positive or equal to 0 is okay. Fair game? So domain is everything that makes x squared plus y squared minus 1 bigger than or equal to 0. Okay. If you watch the pre-lecture, it tells you the inequality in pre-calculus when we did inequality. But let me remind you, this inequality, if I want to draw the solution to this inequality, I first of all set it as equal. If I set this as equal, what do I get? I get a circle. Circle is included. So I draw this circle of radius 1. This is 1. Then use test points. For either inside the circle or outside the circle. What is a good test point inside the circle? 0, 0. Does 0, 0 satisfy the inequality? No. You can test another point, let's say 2 and 0. That is outside. And it would satisfy. So the outside is the answer. So I use the inequality to find a boundary. To find boundary. I use the equality. Then I use a test point. And test point 0, 0 didn't work, so it's the other region. Boundary divided the entire space into 2 pieces. Imagining these things are kind of important, and I'm trying to, I was just talking to my daughter, and she said, everything that I do, and she's an engineering, a graduate student, and she said, everything that I do has to do with imagining how the space is divided. And it's so true. If you want to get further in, everything is about imagination. We give you a lot of possibility to do that in Calc 3. So that's one thing. Everybody's okay with this? Yeah? Let's move on to the next one, and then I want to talk about the graph of the function. That's when things get funky and pretty. I like the funky and prettiness of it. So now, here, do you guys want to, one other thing that I want to say, I forgot to talk about range. Bring it back. this page. What do you guys think the range of this thing is? What are the outputs that you're expecting out of this? Are you expecting any negative number? No. Can you expect 0? I can expect 0. I can plug in x equal to 1 and y equal to 0, and I get 0. There are multiple points that has everything on the boundary. Right? Can I get any positive number? Yes, so the range is 0 and infinity. That's the domain, that's the range. You can also write the domain in the format that I wrote before. I just didn't leave any space for myself. Domain also can be written as this. X and y such that x squared plus y squared minus 1 is bigger than or equal to 0. And the range is this. That are the same. One other thing that I want to say is that this function is a composite function. Funkily enough, the outer function is a function of one variable. The inner function is a function of two variables. Right? I can write this as h of x equal to square root of x, and g of x and y equal to x squared plus y squared minus 1. Composite them together, it's still going to be a function of two variables. Talk to each other for 30 seconds. I think you guys need a little break. 30 seconds, go. Do you want to ask me questions? Ask questions. No? We're good? Was okay? Back? You okay? Also gives me a little chance to look at your faces, because if I don't look at your faces, I never can figure out your names. Ever. Okay, can I start again? Ready? Let's start back again. With that story that I told you, is this a composite function also? Is this a composite function? What is h of x and y? What is g of x? H of x, g of x looks like the outer function. It's a reciprocal, right? 1 over x. What's the inner function? Exactly. Right? So the composite of the two of them also would work. Now let's go back. What is the domain of this function? When is this function? What value can I not plug in? 0 for the denominator, right? So when the denominator is 0, it's not good. So I want the denominator not be 0. The reason this picture is here is because it's very difficult to draw this with pen. With pencil, you can do it. You can draw a big filled out rectangle, then basically erase a line out of it. Because what is this? This is just x plus y minus 1 equal to 0 is a line. And you are excluding it. Excluding a line. So everything but that line is the domain. So I can write the domain as x and y such that x plus y minus 1 is not 0. Right, fair? And that's the shape. I'm not drawing it because it needs a pencil. The pen is not good. Now, my question is, can you guys tell me what the range of this thing is? What's that? There will be a gap. How do you know? Because of that. Do you guys know this one has a gap? Where's the gap for that one? 0. So because this is GOH of x and y, the gap is going to be, range is negative infinity and 0, union 0 and infinity. Okay, one more quick one, and then I want to go to the graph, because graph is the fun part. Now, here, what is not in the domain? Y minus x squared less than equal to 0 is bad. So domain is x and y domain, x and y, such that y minus x squared is bigger than 0, strictly bigger, no equal sign. When I draw this, boundary is y minus x squared equal to 0. Is y minus x squared the boundary included in the solution? No. Why is it not included? ln of 0 is undefined. This is not equal sign. Not equal. Right? So this boundary not included. Draw the boundary. It's a parabola. Give me a test point. 1 and 0 is here, right? Plug in 1 and 0. For x, 1. For y, 0. Is it satisfying? No, 0 minus 1 is negative, so it's not satisfying. So the test point, bad. Therefore, you can check another point too, like 0 and 1, right there, and see that that's the answer. So imagine it also. Imagining it is important. Now, what is the range of this function? What is the outer function here? ln. What's the range of ln? It goes whoosh. Do you guys remember? Draw it in a negative infinity to infinity, right? Range, because natural log is whoosh. Why is it whoosh? I don't know. That's the noise that I like. So let's go to graph of a function. How many minutes do I have? 2. Can I use my 2 honestly? Okay, we're doing the 2. So what is the graph of a function? Look at this. You have a domain. Look at this floor over here. That's the domain of my function. When you plug in one point in the domain, you get a z-value. So if I give you a z-value for each point, there's a point in the xy z in the 3D. Another point here, another point. So it makes a surface. So graph of a function becomes a surface. So it's all x, y, z, such that f of x and y is equal to z. Can I show you a picture before you go? That's the first. That's the domain. That's the picture of that. This is the graph of this function. Do you see that hole? This one is this function. Let me turn this around. You can see the gap, the line that is gone. So and then the last one is this one. And again, you can see the domain in there. Bye, guys. Sorry.